Good afternoon, everybody. So the question that we've posed for this session is, what's next in analytics? AI has burst its way onto the scene and into the public's imagination in a really big way over the last couple of months. And really, all of those sort of similar products, both be it sort of text related or images, they're only limited by people's imagination. But whilst in project delivery, there have been some very specific targeted sort of uses of artificial intelligence for some time. The fact that this really powerful set of tools is so suddenly accessible to so many people is a bit of a wake-up call, but not yet for everybody. And even with all these opportunities, there are still significant kind of barriers to adoption that need to be overcome for technology generally, but also data and analytics more specifically. Today, what we can do is turn that box upside down, shake out the contents, and then flatten it and put it in the recycling. We've got three fantastic speakers who are each going to kind of speak for about 10 minutes and then allow for plenty of time towards the end for audience participation. First off, we're going to hear from Ed Burns, who's the COO at Mafic, a tech startup at the front line of attempting to build trust and engage end users to make better use of their data. Then we're going to hear from Luis Lattuf, who's a PhD researcher in project data analytics at the University of Warwick. He's going to share some of his research that's been conducted in collaboration with industry and dig into some of the drivers for change. Then we're going to hear from Yixue Shen, who's a PhD student also at Warwick University, who's going to show us that even with really quite noisy project data, it still is useful when you start to model it in the right way, and discuss the feasibility of using these models to be able to predict project performance. So after that, as I said, we'll have lots of time for our live audience and to hear lots of your questions and probe some of these topics. I'll pass over to Ed to kick us all off, please.
Okay, thanks, Gareth. Hello to everyone listening. At Mafic, we've built a rewards platform that's a bit like Nectar or Clubcard, but we've designed it for construction workers. We can automatically recognize and reward positive behaviors around productivity and safety. And the rewards vary from extra cash in their pockets through to things like t-shirts, jackets, free coffee, and also the softer recognition, kudos from their peers. This positive motivation has quite a positive cultural impact, as well as being able to increase productivity and build rates. So we've been seeing 10 to 20% increases with a positive impact on cost and schedule. And with the technology, we're also generating some really interesting granular kind of project performance information that we can also use on everything from big picture items like how do you optimize a shift pattern to get the best out, through to the tactical workload and bottleneck balancing. Today, what I want to talk you through is the story of the journey that we've been on, because we've ended up tackling the challenges around new technologies by taking a very different approach. Hopefully explains partly how we've ended up with such an unusual value proposition. But this wasn't what we planned from the start. It's actually something that's evolved from what we've learned on our journey. And I'm hoping that those things are things that can be applied more generally in some of the environments that you're all in too. I'm sure everyone here is aware of construction's productivity challenge. We've all seen it firsthand, along with how construction sites can often be quite demotivating, hard, difficult places to work. And we're all engineers, being quite data minded, we realized that there wasn't really a good practical way to measure productivity, particularly at a low level in construction. So we started building a tool that we could use to see where productivity problems were, with the idea that we can then go and fix them. This is what we've built. A wearable device that uses the movement of the wearer's head and some clever machine learning to recognize what activities people are performing. It works like a construction Fitbit, except that because it's on someone's head, we can be much more accurate. So we can recognize not just that someone is using a tool, but it's a power screw, and we can even count the number of screws that they've put in a particular wall. Building all that activity data up, what we can produce is we can produce a sort of activity map. So we use this activity map to understand productive and non-productive activities and then build that up into a way that measures productivity at an individual level. This is what productivity looks like, the average productivity scores for all the fitters on one particular site over a 2-month period. This was our first big surprise. The difference here between the best and the worst wasn't a third or a half like we expected. It's actually a factor of 4. Put another way, the top third is responsible for 3 times more output than the bottom third. So that there's clearly a huge opportunity in here. But our question here was, well, how do we use this data to actually go and make a difference? And when we first showed this to our client at the time, their instinctive response was, well, who are these guys down at the bottom end? What are their names? I'm going to go and talk to them. And I'm sure you can all see the problem that we've got. People are simply not going to want to use technology if it's being used as a big stick. That's where Amazon keeps getting it wrong with its warehouse tracking tech. And I'm sure you've all seen stories about that in the papers. So here's our first big learning. You've got to have trust. In order to build trust, we realized we had to protect the users from the negative use of this technology. So we chose to make the use of the technology voluntary, and will only ever share anonymized or aggregated data with employers. Yet we keep finding that people are taken aback when we say, we're not going to give you data with people's names on it. We're not going to tell you who your lowest performers are. But when you stop to think about it, the only functionality you lose from this is the ability to go and fire the lowest performers. Yet your supervisors already know who those people are, so you already have a way to manage them. And on the flip side, there are huge gains to be made from using the technology. So the bigger picture is it's actually better for everyone not to know who those people are, not to share those names. We don't need to in order to reap the benefits. Now, I appreciate that this trust problem is much more extreme with wearables, but I think if you rephrased it a little, it also applies to any kind of new technology. How do we take away what people are worried about? Find a way to take away the worries, and you remove some of the resistance that we see to change and adoption. Now, I find it quite interesting how embedded this wanting to know who the names is. But my suspicion is it's partly down to management techniques. We're all pretty familiar with applying pressure and cracking the whip because it's an easy way to manage people. But managing using positive motivation is much harder, which kind of leads me back to our story, I guess. We had to solve the trust problem to remove the resistance to change. But did that make people want to engage? No. So how do we access this huge opportunity? Well, we also needed a way to bring people with us. This realization led us to a very different approach, the carrot, not the stick. With hindsight, I guess it's obvious, but it goes against the grain in an industry that's often highly adversarial. So we've put the construction worker first. They get a direct benefit. In our case, it's performance pay, recognition, rewards. And so the dynamic is the same as it is with an Apple Watch or a Fitbit. People come to us for their own devices, and we're seeing 9 out of 10 guys choose to use it on a voluntary basis. Now, these rewards aren't money for nothing because that 4 times difference between the best and the worst performers. The economics are a no-brainer. We found that a 10% bonus actually costs 3.5%, but saves 20% of the labor cost because everyone's more productive. We're reducing costs by paying people more money. Sounds strange, doesn't it? So here is our second big learning. Make sure there's something in it for the user. If there is, they'll come to you. Again, applying this to broader change ideas, the benefits might not be as hard and as tangible as more money, but you need to make sure that people see a benefit from the changes, especially if someone in one place is making a change that benefits a different part of the organization. Finding a way to reflect the benefits back in feedback, KPIs, time savings, praise, whatever it might be, it's really important if you want people to come on the journey with you. And so now we've got people really engaging with the technology, we start to see a cultural impact. Users have suddenly got a way that they can be recognized and demonstrate the value that they add on top of the money, making their work more satisfying. Having people using the technology also gives us the data to go and do the clever stuff, fix the problems, and improve how sites are working. We always thought whether the original opportunity would be, but the impact goes broader than that because we've managed to align people's interests. On one of the sites we work on, a supervisor came to talk to me. I've got a bone to pick with you. Because of what you've done, my guys are hassling me to get them more material before they run out. Previously, they'd have run out, shrug their shoulders. Nothing I can do. But because it now affected their productivity and what they could earn, we'd managed to align their goals in the same direction. So people were proactively looking to solve problems. So we've not just taken people with us, we've actually created advocates for change. And so there, in a nutshell, are my 3 big learnings for our journey. Interestingly, I think all of these things are the opposite to the default culture in the construction industry. Firstly, you've got to have trust. Secondly, make sure there's something in it for the user. And third, remember the power of positive motivation, because the opportunity for it in construction, I think, is enormous. Thank you.
Super. Thanks, Ed. Really great presentation to get us started. Luis, I'll pass over to you now to give us your perspectives.
So, as Gareth mentioned, my name is Luis Lattuf Flores. I am a researcher from WMG, the University of Warwick. And I will briefly talk to you about the barriers and enablers for project data analytics adoption, which is my research topic, and ease of use and usefulness as drivers of change. What we mean by project data analytics? We mean is the use of past and current project data to enable effective decisions on project delivery. At the moment, we are just dividing it into descriptive analytics, so presenting the data in the most useful way, like using dashboards and Power BI, and predictive analytics, so using the current and past data to be able to predict certain aspects of project performance using different technologies like machine learning, as my colleague Yixue will speak in a moment about that. So we know that has been around projects since the beginning. That's why we have project control departments in organizations. But it's curious that even nowadays, where we have more data available than ever before, and more software and technologies, there's actually no evidence of improvement in the project performance and project delivery or decision making of organizations. Especially in academia, project data analytics is not an area well explored in the project management community. We see differences like in other industries like finance or health, where project data analytics has been around or well applied or well explored, and we are a little bit behind the curve in project delivery. So that's why we conducted this investigation commissioned by the Oakland Group, which is called Revolution, Barriers and Enablers of Project Data Analytics in Infrastructure Projects, to understand the barriers and enablers for the adoption of this. So I really encourage people to have a read of this report. We have a really key quotes of the participants in it, which is really, really useful. The main findings of this investigation is that we came with a framework of barriers and enablers to adopt project data analytics, and we divided it into 6 major themes, such as project data analytics standards and systems, universal data literacy, unprecedented change management, PDA-friendly culture, motivations to adopt PDA unknown, and binning data environments. And we, of course, further divided each of these themes into certain factors that can act as a barrier, an enabler, or both, depending if they have it or not in the organization. A quick example, in project data analytics standards and systems, system proliferation is a barrier that the participants told us about. Organizational standards can be a barrier or an enabler depending on the maturity of the organization and if they have the standards in place or not. And doing the basics is an enabler. We also asked the participants to try and rank the most impactful issues. So they came with the issues of data quality, the availability of exemplar cases to know what the technology is capable of doing or work to have quick wins, the scale of the PDA task, then this idea of fear versus confidence that actually Ed is something that he talked about. So if it's just going to be another technology to punish me, so the stick, instead of using it for improvement. And an idea of awareness, not analyst. So the participants thought that we don't need thousands of data analysts to join the project delivery community, but a universal awareness for everyone, for the project managers to understand what the technology is capable of doing, and kind of everyone talk the same language. So after this investigation, we tried to find a way of understanding some of these factors, and we came across this idea or theory that it's called the technology acceptance model, and we modified it a little bit for the project data analytics context. The main idea of a framework like this is to be able to predict the user intention towards using a new technology, in this case, PDA systems. So it revolves around these two main constructs, the perceived ease of use, which is how effortless will the user think is to use the new system or the new technology, or if they're going to need a lot of training or things like that. So how easy it's going to be or how effortless it's going to be for the user. And it's related to the other main construct, which is perceived usefulness. So how it will help the user or how she will perceive the value of the new system, or if it's going to improve the performance, is it going to save her time? So what's the value? What is in it for me? Also that Ed actually mentioned in his case study or in his organization. So that's perceived usefulness. And of course, these two main constructs are related and affected by external variables. Quick example, perceived ease of use can be affected by the individual data literacy, can be related as well to the experience of the person, the culture of the organization, the standards and systems of the organization, how easy it is going to be for the user, and that directly affects the perceived usefulness, which can be affected by the social influence. So if my coworkers are using the systems, how they're going to see me if I use it or not. Maybe I can scale on my job position, things like that. So finally, we tested this framework into several case studies with different organizations. Some of the main findings, all the participants found these two constructs important and relatable to their experiences. We also came with really important quotes of our participants, of our senior participants. For example, this one, something that isn't too difficult to adopt, it is easy to use straight away. Anything that I do from a user perspective tends to be quite well received. So in this case study in particular that we researched, perceived ease of use was ensured by making accessible to a range of people, developing the PDA first for a central data team, training for the new PDA, avoiding complexity and matching the audience and levels for report using it as part of the daily job, having super users or champions to deliver the message was really important, and showcasing how to use it. Finally, perceived usefulness was ensured by adding value and providing new benefits, communicating the vision and the benefits to the user, setting the vision and managing expectations, showcasing the value, and assuring the system output quality.
Super, thanks, Luis. No, that's yeah, fascinating sort of summary of your research, and yeah, particularly links back to some of the things that Ed was talking about around trust and perception and awareness. Yixue, over to you.
I'm Yixue, as Gareth mentioned. I'm also a doctoral researcher at University of Warwick. My research focus is also on project data analytics, but focus on technical side. More specifically is to see if and how we could use machine learning to predict project performance. I have three following objectives, which are, first one is to look at the nature of the real world infrastructure project delivery data. And the second one is to build predictive models for project delivery using machine learning and also use the real world project data. And last but not least is to look at the level of technical challenge required to implement AI or machine learning. So machine learning is not the same as artificial intelligence. It works by looking at what has happened in the past and use this pattern to predict the future. There are lots of popular machine learning algorithms like artificial neural network, random forest, support vector machine. And machine learning has huge overlap with statistics because normally before we do computer algorithms, we have to visualize the data, pre-process the data, clean the data. In terms of in the project delivery term, the machine learning is used firstly to spot historical patterns between some project characteristics and some project delivery performance. Those project characteristics normally include project size, project type, location, procurement type, contract type, project manager, et cetera. And the project delivery performance attributes normally include cost, duration, and it could also include the risk performance, team performance. And the algorithms will then use this pattern to predict a delivery performance for a new project based on these given characteristics. Each time the process is used, the average between the predicted performance and the actual performance is fed back so that the algorithm gets more accurate the more it is used. Machine learning therefore incorporates two function aspects in project data analytics. One is modeling project data, both in terms of project characteristics and project delivery performance. And the second one is making prediction using that machine learning model. After conducting this research investigation, we find that machine learning prediction can be really worthwhile in project delivery. The project performance attributes that we examined and try to predict are project cost and project duration, because these two are the project attributes that we can get numerical data. So we find that machine learning prediction can highlight the cost and schedule overrun in the data set. It can also identify the driver of cost and duration from statistic point of view. It can also identify the predictors of good schedule cost estimate. And also the most important is it can predict if the project is overspent or underspent, if the project is behind schedule or ahead of schedule. So we could say that it is feasible to use machine learning in predicting project performance. However, the data needs to be of good quality. We find that, as Louise mentioned, data quality is the biggest data analytical barriers for project data analytics using machine learning. Because even for those data sets that we downloaded from beautifully integrated cloud-based systems, I have to say that they're still rubbish. There are loads of missing values. They have weird distributions. We have multicollinearity problems. So we need to do a lot of preparation of data. The time that I used to clean and pre-processing the data is even more than the time that I used to build the machine learning model. And also the outcomes are sensitive to the type of machine learning algorithms we use. That's why we need to use a wide range of machine learning algorithms at the beginning and compare and evaluate the performance of the algorithms and select the best performing one to do the final model fitting. So in summary, in terms of applying machine learning model in project delivery, what we can do are first to evaluate the validity of the data. We can understand the maturity of the data set and answer the question, does the data set contain good enough historical data to undertake forecasting reliably? And second one, we can identify project performance parameters and predictors. We normally get a large number of project characteristics in the given data set, and we need to select a group of project characteristics that could be used in machine learning model based on both project management expertise and the statistical analysis. And the most important is it can make prediction. We can have a go of running the machine learning prediction on the data set and provide an optimized machine learning model to predict project performance. In order to do that, what we need is, firstly, we need to know the background and some basics of the projects, of the given projects. And secondly, we need to have enough and complete historical data sets to do the prediction. And also we need to know what exactly the variable is to ensure that we have a correct understanding of what each variable is recording before we can do any data analytics. I put some of the warning here because sometimes we feel that machine learning is magic, but applying machine learning model is highly contextual. There's no one-size-fits-all model that could be generalized to predict project performance. The outcomes is highly dependent on the data quality. Based on our experience, the data could be too noisy to be used. Besides, we cannot promise the goodness of fit of the model before we actually build and apply it. And I have to say that the model will not necessarily be a good fit. We can interpret the model based on the result, But at the end of the day, practitioner needs to make modeling decision based on the context of the project and use the results to support their decision making.